Hey everyone, in this section we'll be learning about what modules and output variables in Terraform are. So modules are used to create reusable components, to improve organization, and to treat pieces of infrastructure as black box. Now this is particularly handy when you want to avoid duplication between multiple environments such as staging and production. If you want to read a little more about modules and how the general structure is followed around them, how you can create custom modules and use it within your code, I suggest going through this documentation here. Now let's go to our code base to build something with respect to custom modules in relation to our use case. Now, if you've pulled in the latest changes from the GitHub repository, you may find an infrastructure directory somewhere here. But if you've been coding along with us, we'll start everything from scratch. So let's start with in our week 6 directory within the code directory. Let's start with creating a new folder called infrastructure. You can call it whatever you like. And within this, we'll be creating two base Terraform files, main.tf and variables.tf. Now you'll find more context about these files and naming conventions in the video that we've mentioned before, which is from the Data Engineering Zoomcamp. But just for context, basically a Terraform project requires at least one .tf file for your base level configuration. You can call it whatever you want, but this is generally the standard naming convention followed. Variables.tf is an optional file to take in your input parameters at runtime or set as default. Now in the root level main.tf file, we'll start with Terraform block, which is used to configure some basic Terraform settings to provision your infrastructure. It looks something like this. Here we've used a required version tag to set our Terraform version that we've installed on the client and to set a basic minimum version. We have also additionally configured our backend explicitly, which can be used to store the state of the Terraform, that is the current set of resources, and to be able to identify what new resources have been added or existing resources have been modified. So in short, the nested block backend defines where Terraform state snapshots are stored. And Terraform uses this persistent state data to keep track of the resources it manages. And without this backend block, generally Terraform would have stored the state in your local directory on disk, that is, but we are explicitly stating that we want to save the state on a remote service such as AWS S3 bucket. And with that, we are also stating which bucket it should be stored in and what should be the file name of that particular state file. State files generally are stored in the file with the file type .tf state. This name is something that you can put anything of your liking. You just kept a project name here, and additionally I might just add a suffix for for my sake, something like stage or test or whatever. We are also configuring the region, which we are keeping standard across all of our projects. And yeah, that's about it. Also, you will require to create the state bucket on your own. Manually, that is. Terraform won't create it for you when you run the Terraform apply commands. So at first, you need to make sure that your state bucket is already created. You'll need to create this manually before you run any Terraform commands. Terraform won't automatically create this for you. So just in order to show you where a state bucket is located and how it is created, we have just done it manually by using the create button option. Sorry. Adding whatever name you want. In this case, it's the project name, and just for notification, I've also added a state keyword to it so that I know that it's a state bucket and it's not supposed to be deleted. I've kept the default configuration here. Please make sure that the AWS region is EU West 1, and then you create it. This is how our state bucket looks like. And within that, we currently have one Terraform state file, which is MLOps Zoomcamp. Now, in order to demonstrate a cross-environment functionality here, and because we are just using one account for our workshop, we'll be segregating different configurations across different environments with the usage of a suffix indicating to that environment. By this, I mean a Terraform state file for staging will have stg appended at the end of its file name, which is MLOps Zoomcamp -stg.tf state. And in case of prod, it would have prod as a suffix to its file name. Similarly, for the CI/CD workflows, it will be named correspondingly. And the resources would also be referred to corresponding to that particular environment name. We'll be talking about all of that in the next sessions. Also know that accessing state in a remote service requires authorization via your AWS configuration. And for this workshop, we've already done that using the AWS configuration, AWS configure command in the previous step. If you use profiles, then please ensure you're basically attaching your profile configuration also along with that. I'll be sharing links in case you face issues regarding configuring your particular profile, AWS profile to your Terraform setup. Also note that accessing state in a remote service requires authorization via your AWS configuration. For this workshop, we've already done that using the AWS configure command in the prerequisites session. But in case you're using multiple profiles or multiple environments, you may possibly need to set a profile additionally in your Terraform block. I'll be sharing a link for that, or how to pass your profile as a runtime argument to your Terraform configuration. In case you have such a custom setup, and if you want to follow through that method, I'll be sharing the resources for that. The next part that we need is the provider block. So it should look something like this. Now, the provider block is actually for the cloud provider we're using. In this case, it's AWS. This helps add a set of predefined resource types and data sources from HashiCorp's AWS module that Terraform can manage. You can look this up on your on the internet. It should be HashiCorp/AWS on the Terraform web page, and you can find the list of modules that you can install via your AWS provider provided by HashiCorp. So yeah, basically provider helps installs the plugins from an official library. And in analogy, this is similar to importing some open source libraries in your Python script, installing and importing, that is. Yeah, and AWS will also require us to configure things like the region, the profile, the credentials we are going to use. Again, if you're using a profile here, you can add the profile tag and whatever profile you've configured in your .aws setup, or you can pass it at your runtime as well. For your region, we have added a variable here, which is AWS region, and we'll be configuring this particular variable in variables.tf. So this should look something like, okay. Oops. Here you go. I've set the default value for AWS region to EU West 1. Additionally, I've also added another variable, project ID, and defaulted it with our project name, MLOps Zoomcamp. This is something that we'll be using again as our tag to append to the resource names, so that we can identify a whole cluster of resources that we've configured just for this particular use case. All right, and now my ID changes this from red to purple because it has recognized this particular variable here. Okay. Yeah, so the next thing we'll use is an AWS plugin called AWS_caller_identity. Which would look something like this. So yeah, this particular plugin can be used to get the ID of our AWS account, and we'll be needing it to create or generate ARN URLs within our project and to reference at an inter-resource level. And in order to fetch the account ID from the entire URI, we are basically creating a local variable here, account ID, and referencing it to the data source that we've just initialized, which is current identity of the type AWS caller identity. And we are asking it to output the account ID information. So think of it this way. Account ID is equal to data dot the recent data type, a data source that we just imported, which is AWS caller identity. Then comes the current identity, which is something that we've just initialized with. This is basically the name of the data source that we just configured. Let's say we call this ABC. Then this should be ABC. So current identity dot. Now, if you again draw an analogy with the classes in Python, then think of AWS caller identity as a class, current identity as the object instance of that particular class. And now we are accessing the properties of that particular class. So in this case, we want to fetch the account ID and save it in a local variable. One difference between local variables and the variables that we've configured here is I like to think of locals in terms of constants, or something that can be used within the local file usage with respect to the scope of this particular code file. Variables is something that you can use across a module, even at a project level, and you can configure them. They are usually used in the context of accepting input parameters at runtime, unless they are explicitly denoted with a default value. Okay. Now let's create a modules directory for our custom modules. These modules would be, as I mentioned in the architecture diagram that I presented before. So we need two Kinesis streams, one on the producer and one on the consumer side. We'll need an S3 bucket to store our model artifacts. We'll need an ECR registry to store the Docker image of our Lambda inference service. We obviously need a Lambda configuration for this inference or prediction service also. And we'll be having a CloudWatch event to trigger this particular Lambda, to invoke this Lambda whenever a new event arrives in the source Kinesis stream or the Kinesis stream on the producer side. So this means we'd be creating a module for Kinesis streams in general, regardless of it being producer or consumer. Then the S3 bucket, then the Lambda, and finally ECR. The CloudWatch event trigger is something that we'll configure within Lambda itself. We do not need to create a separate module directory. If you want, you can do that, but it's not required. Right. So let's start with a simple module, Kinesis, to just to start playing around with our Terraform configuration. So within Kinesis, let's follow the similar convention of the project structure that we've been following. So one main.tf. Basically, that was just an IDE prompt for me to for it to check if I want to add this particular file into Git or not. If you add it to Git, it'll turn green. If not, it will be red. So don't think of it as an error. Yeah, but you can choose to do whatever you like, or add all your Git files at the end of this project also. And comes variables.tf. You can also add an output.tf file, which we'll be talking about later. At the moment, I won't be adding it. Okay, now in the main.tf of this particular module, Kinesis, we'll create a Kinesis stream configuration, something that looks like this. We have basically instantiated this particular stream object of the Kinesis stream resource. Now, what is exactly a resource? A resource can be a physical component, such as a server, or it can be a logical resource, such as an application. And it can contain arguments to configure this particular resource. Could be something like machine sizes, or disk image names, or VPC IDs, so on and so forth. In order to know what variables you need to configure for that particular resource, you can look at the type AWS Kinesis stream, which is a defaulted keyword that should not be changed. You can look this up on HashiCorp's page and see how this particular Terraform module or resource has been configured and what properties does it expect. All right, and then comes the variables part, and basically we need to configure all of these variables to pass it into the resource properties. So let's just have that as well. Right. So these variables are more or less straightforward. So basically we need the name of the stream that we are going to configure, the number of shards that we'll be having within each stream, the retention period of the Kinesis stream, which is for how much time a certain number of messages will be stored. Then comes the shard level metrics, and oh, I have put a wrong description. And tags is something administrative, just for us to identify who is the owner of that particular resource or how was it actually created. And we've defaulted it to our project name. For the shard level metrics also, we have default values. So basically we need to pass the stream name, the shard count, and retention period when we are calling this particular resource. We'll be calling it from the base main.tf file, which I'll show you how in the next step. Another thing that we can configure is also an output variable for that particular module. So we can create an output.tf file, or because there's just one output variable, I'm just going to add it to the main.tf for that particular module. And I'm calling it a stream underscore ARN. This is again a custom value. Yeah, I basically want to, the value is a keyword that you have to use in the Terraform context for a certain value that you want to output. Basically, outputs are special TF blocks that return a specified value after an associated module is created. So in this case, we are basically outputting the value of this particular instance of the AWS Kinesis stream type and outputting the property called ARN for this value. If you want to look at the list of properties that this particular resource type has, you can have a look here. We basically just want the ARN here. Okay. And now going back to your base level main.tf file. You can reference this module that we just created via the source file. So let's just comment this out and try to write it on our own. So at the moment, I want to reference a certain custom module called Kinesis, and I can call it whatever I want. So for at this point, we are actually configuring the producer side of the Kinesis stream. So I'm just calling it source underscore Kinesis stream, or something like Kinesis stream producer, whatever you prefer. And one important tag that we'll be needing for this block is the source argument. And in a string type, we'll now reference to the location of that particular module that we've created. So in this case, it is in the modules directory and followed by Kinesis. Right? And now it'll be throwing an error because it is expecting some properties, some mandatory properties, which we have not assigned a value for. So let's just add some properties here. For my retention period, I want a 2-day window, so 48 hours. Let's keep 2 shards within each stream. And the stream name is something called as I'll just explain to you what I have actually just done. And for the tags, although it is an optional variable because we've already set a default, we'll just add it regardless. So here you go. All right, so yeah, so the retention period we've set is for 2 days. The shard count within each stream is 2. We are calling our stream name something called as variable.source variable.source underscore stream name, which we'll be fetching from the variables file or at a runtime as a runtime argument. And we'll be suffixing it with the project ID. In this case, it is MLOps Zoomcamp. So let's configure this variable also. All right, so we have everything here. Let's see if there's anything. So yeah, this is basically how you reference a particular module. And Terraform treats any local directory referenced in the source argument of a module block as the module itself. And now that we've configured it, let's give it a dry run. So, okay, and now what we do is go to our terminal and change the directory to the folder where we've just created this Terraform configuration. In my case, it is within week 6, best practices, code, and then the infrastructure directory. Just to confirm, let's just ls minus la and see if we've got all of those files that we just created right now. And the first thing we'll do is initialize the Terraform configuration. So the command for this is Terraform init. And if you have multiple AWS profile configurations, then you can pass your profile name with the -- profile tag along with your profile name here. In my case, I just have one AWS profile set as default, which it will be taking it automatically. So let's initialize this. And now it says that it has successfully initialized the remote backend in S3. So it's found a particular bucket and generated a remote file there. It is installing the AWS plugin library from the HashiCorp base. And it has also created a Terraform log file. Yeah, basically the step initializes your directory in a manner that it downloads the provider, installs it in a hidden subdirectory of your current working directory called .terraform. So you'll be able to find that provider here. The next step that we'll run is a Terraform plan command. This also needs to be passed with a profile. And if you have certain variables configured as constants, then you can also pass your variables through wheres. But this is something that we'll be covering later anyway. So yeah, the Terraform plan shows your execution plan and describes which actions Terraform will take in order to create infrastructure to match the configuration. And this is checked via the Terraform state, which is maintained in the tf state file. At the moment, we do not have a tf state file, so we just create one. Right. Okay, so now it's asking for the source stream name because it's a required argument in your base variables. And we haven't assigned any value for that yet. So what should we call it? Let's call it source stream or ride events. Oops. Sorry, just give me a second. Right, I'm back. Okay, so let's just call this something like ride events. Because I think I already have a similar infrastructure created in, as an example, in a different project directory, and I don't want to create any conflicts. Just for safekeeping, I'll just add this tag stg here. And okay, so this is basically your explain plan. It verifies with an existing state file about what resources already exist and what new resources have you configured just now, or any existing module configuration that has changed that needs to be updated. So there is just one new configuration to be added for this particular state or state file, which is the source Kinesis stream. Okay, it looks good. Everything is in green. And now let's do Terraform apply. It will ask the file, the name again. So your Terraform plan does not apply it for you or save the value name in your cache anywhere. It just tells you if you happen to create a resource with such a naming, what would be the plan like. Now, with Terraform apply, you're basically executing a command to actually generate the infrastructure on your AWS cloud now. So yes, I approve. It'll take a few seconds based on your internet bandwidth. Okay, it's created now and it's generated this particular ARN already. So that's nice. Let's go on to the AWS Cloud Console and see how that resource looks like, or confirm if that's created. Now we can go to our data streams and have a look here. So yes, ignore the first two ones because that is something that I had already created via a CI/CD pipeline, which I'll explain in the next sessions. But this is the one that we just created at the moment. You can have a look at the timestamp here. Oops. Yeah. So the name that we passed at runtime was this, and it was appended by the project ID, which we configured into as a stream name in our module. So yeah, congratulations. Now you've figured out how to use Terraform at a basic level and create a custom module and be able to reference it and produce it on your AWS cloud. Now, and for the next exercise, now we'll code the entire pipeline end to end.